Hello friends, so today we will discuss some basic concepts on the permutation and combinations, and we'll see what permutations is and what combination is. So in the part 1 of this lecture I will show you through an example, uh, and, and we will understand the basics of the permutation, what permutation means actually. So let's take an example of these 12. Suppose 1, 2, 3, 4, 5, 6, 7, 10, 11, 12. So these 12 girls and boys. So, so first and foremost, we are willing to make them sit in a bus which is of 12 seater. Okay. So 1, 2, 3, 4, 6, 7. So if these 12 guys are to sit in this, are to occupy 12 seats in a bus, then how do you think, in what number of ways they can actually be seated here? So for solving this, so let's take one. If she has to sit or occupy any of these 12 seats, so for one, basically she has 12 choices to make. Okay, and when she occupies a seat, let's suppose this seat is occupied by her, then the second person will be left with 11 choices. Okay, provided this one seat is occupied already by her, and if two occupies, let's say this seat, then for third person, for her, basically the choices left would be 10 seats. Okay, so she could occupy any of the 10 seats remaining, and so on and so forth. For the last person, the only choice would be left is the one seat. Okay, so this is the case where the seats are equal to the number of persons we're about to say. So if we are willing to take out in what number of ways these persons can be seated, or in other words, in what number of ways these persons can be arranged to sit in these 12 seats. So this is nothing but the product. So product of these numbers. So number of ways, so total number of ways basically is nothing but the product. Okay, so the product of individual choices or choices for the person will give you the total number of ways in which they can be settled, and this holds true for any person when taking first. Let's suppose, if say we are not taking person 1, but we are starting with person 2. Okay, so person 2 is will have 12 choices, and then person 1, if coming next, will have 11 choices, then person 3 would have 10 choices, and so on. So in any particular arrangement, the number of ways in which these 12 seats can be occupied would be the product basically, because it is dependent. So later on I will explain you the multiplicative property or the additive property, when well, there will be multiplication of the choices, and there will be addition of the choices. Okay, so basically just for your understanding, uh, we will multiply only when there is and condition associated with it. Okay, so see here, uh, when person 1 is sitting and person 2 has to sit after 1, Okay, so there is and condition. Don't you think so? Because person 1 will occupy and then person 2 will occupy and then person 3 will occupy and so on and so forth. So that's why the product of these number of choices will give you the total number of ways in which they can occupy the 12 seats. So if say these are countable number of person, if say we have n number of person occupying n number of seats in a bus, then the same thing can be denoted as n minus n into n minus 1 into n minus 2 up till 1. Okay, so this will give you the number of ways, right? So in mathematics we are more focusing on simplifying things. So instead of writing the entire n into n minus 1 and n minus 2 and so on, we simply write this entire product and denote it as factorial of n, a factorial of a variable n. And one thing you need to know is this n should be a positive integer. It cannot be negative, because here we are dealing with the counting things, right? Negative integer would certainly mean we cannot count in negative sense, right? We cannot say something as minus one number of things. We always count with positive numbers, and so we regard, and also zero is also taken together, including this positive integer plus zero. So basically this n with nothing but it will be a whole number. It cannot be negative. Okay, so this thing you need to remember. So now coming to this n factorial. So the entire thing, n into n minus 1 n minus 2 up till 1, this entire product is denoted as n factorial. And this n factorial is the number of ways when the entire n things has to be arranged in a specific order. So now let's do a question using this n factorial. Okay, let's suppose you are given a question to solve 2n factorial by n factorial, and what would be the value of it? Okay, so most of the people would do a common mistake, like they think this 2n factorial as equivalent to 2n factorial by n factorial, and they will cut and will write it as 2, but this is wrong. That's why I gave a bracket. Okay, 2n factorial would mean a series like 2 into 4 into 6 into 8. So when you put n is equal to 1, it's 2, n is equal to 2, it's 4, n is equal to 3, it's 6, and so on and so forth up till 2. Right? So the same expression we would like to solve like this. So let's suppose it's 2n. So 2n factorial can be written as like this: 2n into 2n minus 1, right, into 2n minus 2 into n minus 3 4, so on up till 1. Sorry. So this will be up till 1. Okay. So right now we are simplifying the numerator. Okay. So when you write, when you try to simplify, we try to group these even factors which has a factor of 2 into 1. So when we bring it down, 2n multiplied by 2 times n minus 1 multiplied by 2 times n minus 2 and so on, multiplied by 2n minus 1 which is odd, n minus 3 and so on up till 1. Okay, till. So now when we take out these two as a common factor, so basically these two are multiplied n times, so 2 to the power n. This is multiplied by 2n plus 1 into 2 into n multiplied 2n minus 1 into 2n minus 3. So basically this is 2 to the power n, and this particular thing is nothing but n factorial. Okay, now we have in denominator n factorial. So when we say numerator upon denominator, to solve this, basically my numerator would come out to be 2n into n factorial and 2n minus 1 into n minus 3 divided by n factorial. These two is cancelled out. Okay, so we in the numerator we are left with 2 to the power n sorry 2 to the power n into this thing. So our solution is nothing but 1 into 3 into 5 into dot up to 2 minus 1. So this is my answer. Okay, understood? This is my answer. Okay, now let's solve another question to understand solving equations involving factorial, and then we'll have a glimpse of the properties of factorial, and then we'll move on to the fundamental principles of counting. Okay, so solve question number 2, which is if n factorial divided by 2 factorial by n minus 2 factorial and n factorial by 4 factorial into n minus 4 factorial is said that these are in the ratio of is to 1, then find value. Okay, so this question we have to solve. Let's try to solve this. Okay, so in my question it is given that n factorial divided by 2 factorial into n minus 2 factorial, and will, so let's first simplify this thing. Okay, so basically n factorial can be written as n into n minus 1 into, we are solving this first. Okay, it's 2 factorial, because anything coming afterwards will sum up to give this n minus 2 factorial divided by 2 factorial. So these things will be cancelled out. and this would ultimately give me as n into n minus 1 by 2. Because 2 factor is nothing but 1 into 2, so this will be 2. So this solves me, this simplifies my first part. Okay, now in a similar ways I'm solving for the second part. So this is my second, this is my first part. Solving for second part, so n into n minus, similarly n into n minus 1 into n minus 2 into n minus 3 into n minus 4 factorial. So this is divided by 2 factorial into n minus 4. These two is cancelled out. So this would give me 2, 3, 2, 4. So now the question says this divided by this are in the ratio of 2 is to 1. Okay, so we'll try to divide this. So we divide 1 by 2. So when we divide this, we have already simplified my 1. So 1 divided by 2 will basically give me into n minus 1 by 2 divided by n into so 2 is 3 divided by 4. So we try to solve this. So n into n minus 1 by 2 here. These things will be cancelled out, and basically we will be left with this entire thing will be so 12 divided by n minus 2 n minus 3, and this is nothing but 2 from the question. So 1 by 2 is basically in the ratio of 2 is to 1. So this is nothing but divided by 1. Okay, so this, solving this would be 2 into n minus 2 into 3. Okay, so 6 basically n minus 2 into 3 is basically 6. On solving, so this is basically a quadratic equation, right? So on solving this would give me n square minus 3n plus 2n plus 6, 6, so 6 cancelled out, so n square minus 5n would be 0, n minus 5 is equal to 0. So this would ultimately give me two cases, two values of n. N is either 0 or n is either 5. Okay, so our answer is basically, I hope you understood the problem, and yeah, so someone is having doubt saying that why not n is equal to 0 is taken. Okay, so basically n is equal to 0 is not meaningful in this case, because uh, we are only dealing with the countable nouns as such. Okay, so n is equal to 0, so basically n is equal to 0 if we are taking, then we have to take a number for which all the uh, all the condition of these if this question would stand true. So if we take n is equal to 0, 0 factorial is 1, 0 minus 2. So factorial notation cannot be negative. So we have already discussed in the above. So factorial, anything inside factorial cannot be negative. So the n is equal to 0 will not be the answer. So n is equal to 5 will hold true for both these expressions. So n is equal to 5 is our actual answer. So is equal to 5 is actual answer. So today we are wrapping it up. So tomorrow we will discuss a few properties of factorial notation, and then we'll see the multiplicative and additive addition principles of counting, and then we'll move on. Then we'll do some numerical problems, and then we'll see the combinations. Okay. Hope you enjoyed. Please like, subscribe to see the further videos in this series. And if you like the sessions, please share it with friends and others in contact so that they are also learning. Thanks everyone. So